Hey everyone! In this video, we will be exploring the S&P 500, specifically looking at the top 100 companies. The S&P 500 is one of the most widely used indices for measuring how the stock market is doing. It essentially looks at 500 of the most important companies to give its index. The data we will be using in this analysis is primarily company data. Let's explore what we have in there. Starting with a known company, say Netflix, we can take a look at its properties. There's almost 200 properties here. Let's explore some. We can get the image, the revenue per employee, the number of employees, and many other properties. Not only can we get current data, but also historical data. Using the dated function inside entity value, we can indicate a time interval, and in here I'm indicating all. This returns a time series which we can plot using dateless plot. It looks like Netflix's revenue per employee has increased a lot. What about net income per employee? What we can do is use entity value to get a list of net incomes and number of employees over time by applying the dated function to the Netflix entity. After that, we can apply divide on our data to get the net income per employee. This also looks like it has increased significantly over time. So for large companies like Netflix, where are they usually? Setting up a variable large companies, we can take the largest 10,000 companies in terms of revenue by using the take largest function inside entity class. Plotting this data using a geohistogram shows the concentration of large companies in North America, Europe, and East Asia. Onto the S&P. We already talked about it a little, so let's get right into exploring it. Using entities, I can call the closing price of the S&P over 2020. What I get is this time series, which we know we can plot using dateless plot. The percent symbol here simply indicates the previous output. We see a sharp decline in early March, followed by a sharp increase after. What we can also do is visualize this through a candlestick chart, which accounts for both opening and closing prices. Calling the SP 500 data directly inside it and setting the range as between January 2nd and today, we see a much more detailed picture of the evolution of the S&P. Let's visualize one more thing. You can see that the S&P is very hectic at times. What we can do is take the moving average. I was also curious about the volume of purchases of stock for each date. Luckily, there's a neat function for this, trading chart, in which I can call the S&P directly for this year and indicate I want a simple moving average and the volume of purchases. We see that volume spiked right when the S&P dropped. Okay, now we explored the S&P index. What about the constituent companies? Let's dive right in. Let's get the entity list of the S&P. I was curious, are there truly 500 in there? Taking the length gives 505, which is surprising. So what type of entity is in our data? Taking the first element in there and getting its full form gives us that it is a financial entity. We instead want the company entity. Perhaps there is a property for that in the properties for our financial entities. Exploring the properties of financial entities, we find that the company property is right here. So what we'll do is set up a new variable, S&P 500 companies, and get the entity value company for all financial entities in the S&P. What sectors are popular in the S&P? Taking the sector property using entity value, tallying the data using counts, and sorting it in descending order using reverse sort gives us that the most common type is industrial companies, followed by electricity, utilities, and business services. I was curious, is the S&P simply the 500 biggest companies in terms of revenue? Well, let's find out. First, we'll get the list of the largest 500 companies by total revenue using entity class and entity list. Investigating their sectors using similar code from last time shows us that a lot are in the oil and gas industry, while banks and telecom services also make up a big portion. To find how many intersect between the two lists, we can use the intersection function applied on them and take the length of that intersection, which gives us only 139 companies. So we can easily conclude that there must be other criteria. We visualize the location of the top 10,000 companies in terms of revenue, but what about the S&P? What I did here is set up a new variable in which I tally up the cities of the companies in the S&P. I then proceeded to plot it using a geohistogram, which shows that the overwhelming majority of companies are centered in the United States, specifically the Northeast. Finally, on to answering our question. Let's start with revenue. Within S&P 500 companies, let's visualize the total revenue through a word cloud. We see that big companies like Amazon and Walmart dominate. What about gross profit? I can set up similar code where I am getting the gross profit property of my companies and setting up an entity association. This time, I'm only selecting companies which had any profit whatsoever using select. The green hashtag and ampersand indicates a pure function. You can think of the green hashtag as your x in a normal function. Using select will map this pure function onto the data and keep only those which pass the test. After that, I can sort the data in descending order using reverse sort and then put it into a dataset. I can also visualize this data using a word cloud. Here, the percent symbol indicates the previous output and the double percent symbol indicates 2 outputs ago. We again see the big companies dominating. The word cloud is not really the best visualization though. What about using a pie chart? Let's try it. Also, let's get a numerical answer for how much the top 100 companies dominate by getting the total profits in the top 100 companies and dividing it by the total profits across all companies. Plotting the total of the first 100 and the total of the rest gives us the following pie chart, which shows a heavy skew towards the biggest 100 companies. Now, what about market cap? We can do the same thing here and set up a new variable in which we set up an entity association between the financial entities and their market cap. We can make a dataset and word cloud out of this like we did last time, and it looks like there's an even narrower set of companies dominating the market. Dividing their total market cap by the market cap of the entire S&P and plotting it using a pie chart gives us another skewed visualization. I encourage you to make use of the variety of data that we have about finance and the stock market and the Wolfram language. There's so much to explore, so go ahead and get into it.